Hello friends, I am Karishma Varpe. In this video, we will see the concept of magnetic fringing effect.
First of all, we see magnetic linkage. What is linkage? The linkage is the linking of magnetic field with the conductors of a coil when the magnetic field passes through the loops of the coil. The linkage flux is the flux which completes its path other than the air gap. The flux produced by magnetomotive force do not pass through the intended path. As shown in figure, few flux takes the shortest possible path. The flux which does not take intended path is called linkage flux. This flux is not useful flux. Let's see the simple diagram. In this diagram, first of all, we take the iron core. In this iron core, the copper wire is wounded on the iron core and current I is passing through the circuit and create magnetomotive force which flow the path of magnetic flux. Iron core flow the low reluctance path and they provide air gap between them and they flow the flux gap. When we create magnetic flux with the help of magnetomotive force, the magnetic flux is the flow of magnetic path, but in this case some flux does not flow the path of magnetic flux. They flow some shortcut path and they complete its path other than air gap, and that means some flux will be linkage. So we take this example of pipe. In this pipe, water is flowing through higher level to the lower level. In this process, the small hole will be there, then water will be linkage and goes to the earth is called linkage. Some condition will be here to see in this diagram.
We will discuss the magnetic fringing effect. First, we will see what is the magnetic fringing. We should know about the fringing effect is occurs in air gap is present. So, when flux passes through the air gap, it's having tendency to bulge out. This bulging effect increases the effective area of air gap and hence the area of air gap increases and flux density of air gap decreases. This phenomenon is called as fringing. Fringing effect is equal to area increased due to fringing upon actual area of magnetic path. Now we see the effects of magnetic fringing. First, due to spreading of flux at the edges of air gap, the effective cross-sectional area of the air gap increases. Second, due to increased cross-sectional area, flux density in the air gap reduces. Third, flux density of the air gap is different from the flux density of the core. Fourth, air gap introduced in order to linearized BH curve. Magnetic flux saturation is not reached due to air gap. Leakage flux and magnetic fringing are the undesirable phenomena. Because of magnetic leakage, useful flux in air gap decreases, and because of magnetic fringing, flux density in air gap decreases. Hence, to obtain necessary flux density in air gap required, MMF is increased. Flux produced in the air gap is useful for many applications such as relays, motors, generators, moving coil and moving iron, measuring instruments, etc.